Hey there, this is MathCamp321, and in this video I'm going to show you how to integrate exponential functions. Here are the rules. If you're trying to integrate e to the x dx, you're simply going to end up with e to the x plus c. We can generalize this by saying if we integrate e to the u du, we get e to the u plus c. Let's take a look at a specific example. Number 8. Integrate e to the 3x plus 1. Well, we want our integral to form fit to one of the two rules up above. This is going to require a very basic u-substitution, so let's go ahead and allow u to be 3x plus 1. Differentiating with respect to x, we get du equals 3dx. We don't need the extra 3, so I'll divide both sides by 3. My next objective will be to rewrite the original problem exclusively in terms of u. Now instead of e to the 3x plus 1, I'm simply going to write e to the u, and then instead of ending with dx, I realize that dx is the same as 1/3 du. So I'll put the 1/3 out in front because it's a constant, and I'll conclude with du. And now it looks exactly like rule number 2. So the answer is just going to be 1/3 e to the u plus c. And I'll complete the problem by back substituting. Let's check out example 9. Integrate 5x times e to the negative x squared. So for this problem, I know I'm in the category of integrating e to the x, but there's a little bit more to it. We've got that 5x in front, and the exponent of e is a little bit on the complicated side. So I think I'm going to start by just pulling that 5 out in front of the integral symbol. Now, because my exponent is a little bit more complicated than just a plain x, I'm going to allow u to be negative x squared. Differentiating with respect to x, we end up getting du equals negative 2x dx. I don't need the extra negative 2, so I'll divide both sides by negative 2. Now I'm going to go back to my original problem, and I'm going to do one more thing. I'm going to take the product of x and e to the negative x squared, and I'm going to just reverse them. At this point, I can take my originally stated problem and rewrite it exclusively in terms of u. Notice how this problem ends with x dx, as does this step in our substitution. So I can replace that with negative 1/2 du. So I'll conclude with du, and then I'll place the negative 1/2 in front, making the front really negative 5/2. So what we end up with is negative 5/2 e to the u plus c. And one final step involving back substituting gets us negative 5/2 e to the negative x squared plus c. Let's go on to the next slide. In example 10a, we're asked to integrate e to the 1 over x squared dx. Since the power of e is something more complicated than just an x, it warrants using u-substitution, and I'm going to allow u to be 1 over x. I'm going to rewrite this more calculus-friendly as x to the negative 1. Now I'm going to take the derivative of each side with respect to x. And I'm going to rewrite this without negative exponents. Now you'll notice there's a negative floating around, which I don't need because there's none in the integrand. So I'm going to multiply both sides by negative 1. Now I'm going to take my originally stated problem, and I'm just going to reshuffle things just a little bit. By perceiving the problem this way, I think it's going to be very, very easy to do our u-substitution. Instead of e to the 1 over x, I'm going to simply say e to the u, and as this ends in 1 over x squared dx, so too does this, 1 over x squared dx, and that can be replaced with negative du. So this is going to turn into negative e to the u plus c. And now I'm just going to finish by back substituting. Negative e to the 1 over x plus c. In example 10b, we're asked to integrate sine of x times e to the cosine x. And once again, we've got a power of e that's more complicated than just an x. So I'm going to allow u to be cosine x. Differentiating both sides with respect to x, we end up getting du equals negative sine x dx. But my originally stated integrand doesn't have a negative, so I'll multiply both sides by -1. Now I'm just going to reorder my integrand just a little bit. Once you get good at these types of problems, that step probably isn't necessary, but I just want to make it very, very clear how I'm doing the u-substitution. So at this point, I'm going to rewrite my originally stated problem exclusively in terms of u. So instead of e to the cosine x, I'm just going to write e to the u. This ends with sine x dx, as does this over here. So sine x dx can be replaced with negative du. And now we have negative e to the u plus c, and we'll back substitute and be done. So we have negative e to the cosine x plus c. Great! Let's go on to the next slide.